Look at this demo. Kimi K3 is generating an open world, a handheld games, and other playable scene. The exciting part is not only the visuals. The real question is the vendor. The models can write code, inspect the result, and improve it. A user can describe a page, show an image, or provide us a visual reference. The system then creates a working design and allows the further change through conversation. You can speed up early prototyping, but the generated website still needs a human check for accurate text, responsive layout, accessibility, performance, privacy, and security before we publish. Kimi presents the game development as an example of long, connected work. The model must create terrain, light, movement, control, and a working camera. It also needs to run the project and look at the result. Kimi calls this person in the loop, write the code, capture a live screenshot, compare with the goal, and correct the visible problem. This can be useful for prototyping, but a police record does not prove the entry project is stable. A developer should still test the control, performance, save state, and the quality of the generated code. This additional sense shows that the same flow and can produce very different visual styles. The important test is whether another developer can open the project, reproduce the result, and continue to work. Kimi also published the result for coding and agent benchmark. This chart compares K3 with the several other models across the software engineering, terminal tasks, programming problem, and internal evaluation. Benchmarks are useful, but they are not the same as a real production project. Scores can change with the prompt, available tool, time limit, reasoning, setting, and evaluation method. Kimi says the result use maximum thinking effort, so they should be understood as company published measurement under specific conditions. My preferred test a practical, give the model a real repository, clear requirement, version control, and automate tests. Then review whether it solves the task without breaking existing features. Beyond coding, Kimi presents K3 as a model for knowledge work. The example include research, report, presentation, and tasks that require information from many documents. A light context window can help the model keep small project material together, but it does not guarantee correct conclusion. Importance number, citation, and dates should always be checked against original sources before they are shared. This is where human judgment becomes essential. I would not publish an AI website, report, or code change without reviewing it myself. AI can accelerate the first draft while the creator remains responsible for accuracy, security, and the final decision. The architecture section explains how K3 moves information through the model. Kimi highlights Kimi beta attention, often shortened to KDA, and attention residual. Instead of relying only on one standard residual stream, the diagram shows connections that help information to move across multi-layers. K3 also uses a mixture of expert design. Many specialist components exist inside the model, but only a smaller group is active for each token. This approach is intended to provide high capacity without using very parameters for every step. Architecture diagrams can explain the design, but they do not provide a better user experience by themselves. What matters is whether the system follows instructions. Use tools safely, preserve context, and completely long tasks reliably. For developers, that means testing the model, a real repository, and review every important change before merging. The next animation focuses on quantile balancing. In the mixtures or experts model, some experts may receive too much work while another receive very little. poor balance can reduce efficiency and limits how well the model learns. The animation shows token scores, expert, load, and the thresholds that separate heavier and lighter group. The system adjusts the routing so that work is shared more fairly. This is a technical training and architecture concept, not a feature that most users control directly. Still, matter because effective routing can affect speed, capacity, and model quality. When watching this diagram, remember that they are explanations from Kimi. Independency testing still needs to compare the real-world performance, cost, reliability, output quality across different models. Expert routing decides which specialist component process each token. The animation begins with scores for many possible experts. It then selects a smaller group and adjusts how it works distributed. Different tokens may follow different paths, following parts of the network to specialize. Kimi reports that K3 active 16 experts from a much larger pool for each token. The goal is to combine a very large model with a more efficient computation. This design is impressive on paper, but model size and architecture are only part of the story. A useful AI system also needs reliable tools, clear boundaries, good error recoveries, and a user experience that makes an action understandable. Kimi itself describes limitations, including sensitivity to the model thinking and the possibility of unexpected decisions. For important tasks, I would use checkpoint, backups, tests, a human approval before any destructive action. That is how impressive technical ideas become trustworthy work. My conclusion is that Kimi K3 looks ambitious, especially for visual code and long agent tasks.